Hi guys, and welcome to the pre-algebra midterm final review, numbers 1 through 79. I'm going to go through these kind of quickly, so pay attention. And if you've already completed this sheet and you have a couple questions on some, just go ahead and fast forward to the one you need help on. Okay, so let's get started. Number 1, what is the opposite of 5? Now, when you think of a number line, you have 0, 1, 2, 3, 4, 5, but on the opposite side of 0 is negative numbers. So the opposite of 5 is -5. Make sense? Think about that number line. You have 5 over here, and you have -5 over here, so that's the opposite. How about -10? So -10 would run over here. The opposite of -10 is 10. Next, number 3, order these numbers from least to greatest. Now you're going to look at the negative numbers first, because negative are going to be on the left side of the number line, and the positives are going to be on the right side of the number line. So if I look at my negative numbers here, I have -30 and -5. Start with those. So -30 will be first, -5, and now we're going to move to the other side of the number line, or to the midpoint actually. So we have 0. Then we also have 4 and 1.3. 1 comes before 4, so 1.3 and then 4. Next, compare the following numbers by using less than or greater than. Again, looking at a number line, 0 right in the center, 4 is going to be on the right side, -4 is going to be on the left side. So we're going to look at our first number here and say -4 is less than or greater than 4. Well, -4 is less than 4. You're going to open up the symbol to the greater number and close the symbol to the smaller number, like an alligator's mouth, opening up to the 4. How about B? -6 and 3. Well, on a number line, here's 0. -6 is further to the left, and then -3 goes to the right, positive. So -6 is less than -3. Sometimes we get tricked right there because we say, oh, 6 is greater than 3. But remember these negative signs here. -6 is further to the left on the number line, so it's less than -3. Okay, number or C here. We have a positive number, 3, and we have a negative number, 13. So obviously this negative number is less than 0. It's 13 to the left side of the number line, so it's going to be less than 3. So 3 is greater than -13. 5 and a -6. Just check out, this is a negative number, so -6 is less than 5. So 5 is greater than 6. Moving on, number 5. We have -3 plus a -3. So remember, when you have a positive, when you're adding and subtracting, when you have a positive and negative together, that translates to a negative. A negative and a positive is a negative. So if I were to rewrite my problem, -3 minus 3, now I'll look at the number line here, 0. I'll go to the -3 spaces to the left. So let's just say it's there. So 1, 2, and -3. And then I'm going to go an additional -3 spaces, but negative. So we're going to keep moving to the left. 1, 2, 3, and that's going to land me at -6. So -3 plus a -3 is -6. So 2 -3s gives you -6. How about -2 plus 9? If we were to draw our number line, I will start at the -2, and then we're going to add 9. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and land on a +7. Oops, it's a +7. Make sense? And remember our little trick there, our little song. You have a negative and a positive. You take the sign of the greater number. You subtract those two and take the sign of the greater number. Remember our song, same signs, add and keep, different signs. subtract, so 9 and 2 gives you 7, and then keep the sign of the greater number, then you'll be exact. I'm not a good singer, but that's another little song you can remember. How about number 7? 50 plus -2. So again, we have a positive number here, and we have a negative number. Again, remember, the positive and the negative give you a negative. So I could rewrite my problem as 50 minus 2, okay? And 50 minus 2 is 48. Again, different signs, subtract the 2. Keep the sign of the greater number. Even though it doesn't have a positive sign, it's implied, so keep that positive sign. Number 8. You have a -4 and a +4. Those are going to cancel out, because if you have a -4 and a +4, that gives you 0. So you're back to 0. Plus 13 minus 13. Well, those cancel out too, because if you have 13 apples and you take away 13 apples, you have 0 apples left. So our answer is 0. Number 9, will the answer be positive or negative? We have a -10 plus 13. Again, let's sing the song. So different signs, subtract, okay? Keep the sign of the greater number. So our greater number is 13, so it's going to be positive. You can just put a plus sign, or you can write out positive. Number 10, it looks like an order of operations problem because you have positives and you have a negative here, but it's actually an addition and subtraction problem. So you can use the commutative property of addition, so you can move all these around if you want to, but we'll just go left to right. So we have a -7, and what I've showed you guys in the past, let me just do it again. Just go ahead and block the rest of the problem to keep it simple. So -7 plus 11, again, we have two different signs. Keep the sign of the greater number. So 11, subtract those two. 11 minus 7 is 4, and you're going to keep the sign of the greater number. So that's positive. Let's keep moving on. Now we have a positive and a negative. When you see that, make that a negative, because positive and a negative give you a negative. And then you're going to have 14. Let's keep moving on. Plus 3. And then you can just use the associative property, commutative property rather, and just move those around as much as you want. So I'm going to just add those two together. Plus 3 and plus 12 give me a positive 15. And now we'll just go and add those and subtract. So 4 minus 14 is a -10. Again, you have a negative and a positive. So when you have two different signs, just pretend there's a positive there. If it's blank like that, it's a positive number. Two different signs, you subtract to get the difference, which is 10, and then you keep the sign of the greater number, and that gives me -10. Plus 15, and that will give me, again, a positive and a negative. So subtract the 2, you get a 5, and then keep the sign of the greater number, so you get 5. Next, 11. Write 2 to the 5th power as repeated multiplication. So this exponent tells me how many times I am going to multiply the base, okay, of 2. So in repeated multiplication, you're just going to simply write 2 times 2 times 2 5 times. And that's what repeated multiplication looks like. So 2 times 2 times 2 times 2 times 2 can be written as 2 to the 5th power. But what I want for your answer is to show me that you're going to write it out 5 times. You can use the little times symbol as well, or the raised dot, whichever one. You can even write it like this, in parentheses. All means multiplication, as long as you have 5 of them. Okay, what is the base of 8 to the 3rd power? So our exponent is our 3, if you remember when we're working with bases, and our base is the whole number of 8. So the base of 8 to the 3rd power is 8. Moving on to 13, 3 squared. Again, look at this problem. Your exponent tells you how many times you multiply the base. So you need to multiply 3 2 times, and that gives you 9. So 9 is your answer there. How about this one? Your exponent of 2 tells you how many times you multiply your whole number there, so you can do it like this. Multiply -3 2 times, and that gives you 9 as well, because a negative times a negative is a positive. Okay? -3 squared. Now, I gave you these problems because I want you to see that these are actually different. This exponent is telling you how many times to multiply everything in the parentheses. This one is telling you to multiply, let me get my piece of paper again. You're going to multiply 3 2 times, but you're going to kind of ignore that negative sign, okay? So 3 times 3 is 9, and then you're going to add your negative sign lastly. So that's a -9. So they're similar problems, but you compute them differently. Okay, so for number 16, you're going to have a little background music because I'm on hold waiting to hear from the doctor, but for my mom. But anyway, while I'm holding, I'll let you guys hear some background music, beautiful classical music. So 9 to the 0 power, as you've heard me say, anything to the 0 power is what? 1, right? So anytime you see any number, variable, anything to the 0 power, just put 1. That's the answer. But I am going to show you why and prove to you that 9 or anything to the 0 power is 1. So when you have the number 9 divided by itself, you get 1. Okay? And in division, we can say that if we have, say, 9 to the 5th power divided by 9 to the 5th power, we can also translate that as 9 to 5 minus 5. And that gives us 9 to the 0 power. And we also know that anything divided by itself is 1. So I just proved that anything to the 0 power gives you is 1. Okay? So y to the 0 power is 1. Okay, how about n to the -1? Now, I didn't really give any instruction there, but you really can't ever have unless the instructions tell you to have a negative power in the numerator. So what I want you to do is turn that to a positive exponent. And the only way you can do that is to put...
Thank you for holding. This is Dee. How may I help you?
Okay, so I'm back on hold again. So we have n to the -1 power. So this, oops, anytime you have a number or an exponent, anything like that, it's always over 1. So I need to get this negative exponent to be positive. That's what I'm looking for in this problem. So I'm going to move it to the denominator. Show you over here, which is going to leave me a 1 in the numerator spot, and then n to the 1st power in the denominator spot, and that translates to just 1 divided by n. So that's what you'll put in your little answer slot. I'm on hold again, by the way. That's that beautiful background music.